Hello and welcome to Sci-curious. I'm Pete and today we're going to be looking at Schrödinger's cat. This video does contain gross oversimplifications, so if you're interested by its contents then I can suggest some literature for further reading. Schrödinger's cat has worked its way into so much popular culture these days that chances are you've at least heard of it. If you know exactly what it is, this video is probably not for you. If you think you know what it is, then this video may well clear up some gaps in your knowledge. And if you're thinking, what the fuck is Schrödinger's cat, then this video is definitely for you. So, what the fuck is Schrödinger's cat? Schrödinger's cat is a thought experiment, sometimes described as a paradox, devised by Austrian physicist Erwin Schrödinger in 1935. It came about as a result of his displeasure with the Copenhagen interpretation of quantum mechanics, specifically the principle of quantum superpositions. I'll explain exactly what that is shortly, and it's not as complicated as it sounds, so bear with me. He didn't devise this thought experiment to prove anything, but rather to highlight what he saw as a flaw in the interpretation. In short, Schrödinger's cat demonstrates the conflict between the behaviour of matter at the microscopic level, i.e. the behaviour of atoms and subatomic particles, and at the macroscopic level, i.e. how we perceive the world around us every day. So what exactly is the thought experiment? Basically, a living cat is placed into a box along with a vial of poison. This doesn't have to be poison, it could be a bomb or whatever really, anything lethal, but let's stick with the traditional vial of poison. Now for the crucial part. The box also contains a small amount of a radioactive substance and a Geiger counter. If the radioactive substance decays, thus emitting a particle, the Geiger counter will detect the particle and activate a mechanism allowing a hammer to smash a vial of poison. This kills the cat. Popular culture often misses this final and most important part. Take this scene from The Big Bang Theory, in which Sheldon is explaining the concept to Penny.
A cat is placed in a box with a sealed vial of poison that will break open at a random time. Now, since no one knows when or if the poison has been released, until the box is opened, the cat can be thought of as both alive and dead.
No! What he's described here is just an obvious everyday scenario that you would encounter in classical physics, but we're more interested in what would happen in quantum physics. If we sealed a cat in a box and we didn't know whether the vial of poison had broken, then the cat would be dead or alive. With Schrödinger's cat, the cat is both dead and alive. To understand why, we need to go back to understanding quantum superpositions. To do so, let's take a look at my all-time favourite experiment, the double slit experiment. Yes, so I have a favourite experiment, and what, mate? The double slit experiment demonstrates the way that light and matter can display characteristics of both waves and particles. Sometimes they behave like particles and sometimes like waves, much like any other waves. Waves behave in the same way, be it radio waves, sound waves, or waves in water like you would see on a pond surface if you were to throw in a stone, so the concept is familiar to us all. When waves meet, it creates an interference pattern. Where wave peaks and troughs meet, they create constructive interference, becoming larger. And where a peak and a trough meet, they cancel each other out. Much like you would see on the ripples of a pond, and this is basically how noise cancelling headphones work. In the experiment, a particle emitter, let's use a laser for this example, which emits particles of light, or photons, is aimed at a plate which has two parallel slits. Any light that passes through these slits is recorded on a screen behind the plate. As light acts as a wave, the photons pass through both slits and the two waves cross over after entering the slits, causing an interference pattern to emerge on the screen, which can be seen here in these light and dark bands. In classical physics, if the photons were acting as particles, we would only see two dark bands as a result of the photons passing through the slits. This is even the case if one particle at a time was fired at the slits. The particle acts as a wave and therefore interferes with itself, excuse the phrasing, thus producing the same interference pattern. This is where it gets weird, and why this experiment is so amazing. If the experiment is performed with an observer, which could be a detector, a camera, or a person, then the particles act like particles again, and only go through one slit or the other. This gives us the two dark bands as we would expect in classical physics. Basically, it's as if the photons act like waves until they're observed and they revert to acting like particles. Like, whoa, we're being watched guys, better behave ourselves and act like particles. Very strange indeed. So this is what is meant by a quantum superposition. The photon is in more than one place at the same time until it's observed, at which time its superposition collapses and it is only in the one place. Still here? Right, let's return to the cat. So, the radioactive material inside the box may or may not decay within a given time. If it decays, a particle is emitted and the Geiger counter activates the hammer, which breaks open the poison, dead cat. If it doesn't decay, no hammer, no poison, the cat's alive. He never meant this as a literal experiment, it's just a thought experiment to highlight the absurdity of the theory so you can call off the animal rights activists. According to Schrödinger, the Copenhagen interpretation of physics suggests that the cat is both dead and alive until such time that the state is observed. Physicists often judge an interpretation on how well it deals with the issue of Schrödinger's cat. For example, the many worlds theory, which you all know from the science fiction as multiple universes, not dimensions, that's something else entirely, tackles the issue by creating two realities, one in which the cat is alive when observed and one in which it dies. Every time a quantum event like this takes place, the universe splits in two. Therefore, every outcome that could happen does happen in one universe or another. This is where the theory of an infinite number of alternate universes comes from. So that's it for my brief summary of Schrödinger's cat. Did you learn anything there, or are you none the wiser? Or did I get it all wrong? Let me know in the comments. And also, if you have any requests for future videos, I'd welcome any suggestions. So I've been Pete, and thanks for being Sci-curious.